welcome to another video. In today's video, I'm talking about thermal mass and PC building. So, I built this PC case, and my objective was to have a positive pressure, ruggedized case with focus on being able to clean out the filters simply, okay? So I started testing it. It is summer, so I couldn't do a lot of testing. But I have done a little bit of testing. And of course I'm using the computer to edit. I game
Countdown.
Enemy shield firing.
on it. I've been playing around with AI on it. So while I'm using it, I'm noticing that I'm noticing that my thermals are absolutely amazing. The computer fans never have been over I think 34, maybe 35%. And I actually inadvertently achieved static pressure, which static pressure is technically better than positive pressure because you're still getting the exact same effect as you are with positive pressure, but you don't have any losses. You don't have anything working against itself, where positive pressure denotes you have more fans blowing into your case than your fans can blow out. So there is a bit of overstress potentially on the intake fans. Okay, so targeting static pressure is really probably doable with some sort of computer modeling or something like that. I just kind of nailed it inadvertently. So, but this video is more about why I think this case and the way it's set up is so thermally awesome. So typically you have PC cases and people are getting smaller and smaller and smaller, packing stuff into less and less room. Well, what they're doing is they're creating thermal mass. There's nowhere for the heat really to escape, and there's a lot of places for the heat to build up. In this PC case, there is nowhere for the heat to build up. There's nothing for the heat to grab onto. The aluminum's extrusion that fills this empty void and then the parts are just attached to that is actually a heat sink. So the parts are basically bathed in air. Okay, now when you start to look at water-cooled systems, you have, or liquid-cooled or whatever, you have the liquid. That is thermal mass. You have the radiator, the extra fans, the tubing, the pump, the reservoir. All those things are thermal mass. They're all holding on to heat energy. And I have really not got a way to directly compare this case to water-cooled cases, and I can't do all the testing I want to do. It's still too hot here in the summer. I'm going to go back to testing when it cools off, and then I'm going to get that video out. But currently, what I'm seeing is absolutely amazing. The case just sheds heat in 5 seconds. It literally, you can see here where I run this Cinebench test, and when it's done, look at how fast the heat recovers. I mean, it just drops off a cliff. So if the PC case builders this would be an awesome thing to see Gamers Nexus to actually test, because I think from what I'm seeing, water cooling is kind of a waste is a kind of potential issue. And if you just build the PC cases correctly, the water cooling is actually not as good as air cooling. I think that's what's going on here. So this needs some investigation by people that have all the equipment to investigate it with. But I mean, I'm not going to give you my PC to test, but it's not that hard to, I mean, you know, and this, you might, well, we'll just put it on a test bench. Well, the difference between a test bench is the air just can go whatever, right? There is no uniform in and uniform out of the test bench. So I think that this configuration will actually outperform a test bench as well. So, all right, that's just a quick video about the case. Subscribe if you want to see the video where I actually put the thing to all the different tests to get all the different stats. So, thanks for watching and peace.
Thank you for watching.